Hello and welcome to Exponentials 5.1, the role of A and B in modeling. Alright, so today we're gonna continue studying exponential equations, but today we're gonna start creating them from word problem information. So you're gonna read a word problem, you're gonna figure out which numbers and which words are important, and based on what is being said and given in the word problem, you can form the equation and then you can use the equation to solve something else. Okay? So when you look through all these letters, you're going to see that there's four letters. There's A, B, T, and Y. And A is going to stand for basically how much you start with. Yeah, it's called initial quantity at time zero, but it's basically, when you think about it, it's how much you start with. Okay? And B is going to be your base value, or your rate of growth or rate of decay. Yeah, because it can either go up and down as far as the patterns. And T is going to represent time, and Y it says the quantity represents the quantity at time t. So that sounds kind of confusing. So just think of it as how much you have after the time passes. Okay. So those are the letters that we're going to use, and hopefully it starts to make a little sense as we start to do some problems and see how they all connect. So let's go to our next slide. Okay, so when you read the problems, you're going to see words that are going to indicate either growth or decay. So if you see words that relate to something increasing or getting bigger, then you know it's going to be a growth problem. And the way that we're going to get the b value is we're going to go 1 plus r, where r is the number that's going to tell us how much it's either growing by or how much it's decaying by. Okay, and if you see a word that I guess corresponds with something getting smaller or decreasing, then you're gonna figure out the base value, the b value, based off of 1 minus r. And r, like I said again, is the number that when converted to a decimal value tells you how fast something is either decreasing or increasing. Yeah, at what rate rather, at what percentage rather. Okay. All right, and then sometimes you're not going to have to use the formula 1 plus r or 1 minus r when they have words like doubling or tripling. Okay, so if you have those kind of situations, you don't got to plug it into the r value. It's just going to straight out be doubling means 2, tripling means 3. Okay? All right. So let's see our first example. Okay, so I'm not gonna do a problem live just yet. I'm gonna go over some of the examples. So what do we have here? We have 1,000 organisms are placed in a petri dish, assuming the population doubles every hour. Find the symbolic representation of the population after t hours in the form of p of t equals a times b to the t power. Then find the population after t equals 5 hours. Okay, so your a value is 1,000. You see that keyword doubles, so that tells you that your r value is 2. Okay, and then you got your I guess your formula as far as how it's going to look, or your symbolic representation. Yeah, and then you got the number t equals 5. So after you make your formula, you're going to plug in 5 and see what happens. Okay. All right. So since it says doubles, yeah, you can kind of associate it with an r, but we're not going to really call it r because it's just going to mainly be your b value is 2. Okay. So please don't start to do this and say, oh yeah, 1 plus 2 makes 3, or 1 minus 2 makes negative 1. Don't do that. Yeah. Don't combine it with the 1. All right, just replace the b value with whatever that number is. So the number is going to be 2. Okay, and that's how we get this equation down here, right? So this is eventually our equation, where the 1,000 takes the place of the a, the 2 takes the place of a b, and the t value, we don't replace it because that's going to be the variable in the formula. This is the symbolic representation. Okay, and then when we start using the formula, we're going to erase the letter t, and we're going to put a 5 in that spot, crunch the numbers, and we're going to get 32,000 as the result of how much organisms we have after 5 hours. Okay, so main thing to get success in these problems is to basically know what numbers and words connect to the letters that are going to be used to I guess frame out your equation. Okay, all right, so let's look at number 2. So we've got a little bit different stuff here. We have a 20%, which is going to be our r value, so we're going to change it into a decimal value. So r equals 0.20. The 1,000 is going to be our a value. The word grew implies that it's going to be getting bigger, so we're going to use the scenario b equals 1 plus r. Okay, And then we see the e of t equals a times b to the t power. That's going to frame out our equation. It's going to tell us basically what it's going to look like when I finally get my equation on the paper. And 5 is going to be the number that I plug in after my formula is already made. Okay, so I'm going to circle some things that are going to be important. Yeah, so this thing that I just circled is what your final equation looks like, right? So the 1000 is your a value that we got from the problem. The 1.2 comes from here. Okay, so because this is a 1 plus r scenario, because it's a growth scenario, we're going to add 1 plus your r value of 0.20. And that's going to get plugged in right there. Okay, and then we're going to have our letter t, that's going to be our variable. And eventually when I start using the equation, we're going to plug, what number are we plugging in? 5. We're plugging in 5. And when that gets plugged in, we get a rounded answer of 2,488. Okay? Alright, so I know this is going by fast, but I realize this is a video, so if you gotta stop and rewind and play as many times as you want, that's perfectly fine. Yeah? But I don't want to make this video any longer than it needs to be, so I'm just going to move along. And hopefully everything makes sense. Okay, let's look at the next one. So we got a lot of keywords here, right? We got our depreciate word, so that's going to imply 1 minus r, right? So depreciate means something is going to get smaller, or in parentheses it says loses value. Okay, so it's not going to be worth as much. Okay, in our initial value, our a value is 9,000. My rate, my rate that it's going to depreciate at is going to be 15%. So I transform that into a decimal, so 0.15. And I got my equation as far as what it's going to look like, and it's going to be in the form v of t equals a times b to the power of t. And after I get the formula all made, we're going to plug in 3 to use it. Okay, so as you can see on the problem right here, you can see your equation. It's all framed out, right? It's all looking how it's supposed to be. We got the 9,000 as our initial value. We got 0.85. That is the result of the 1 minus r scenario, right? So because it says depreciates, it's going to be a 1 minus r scenario. So we go in minus 1 minus 0.15, because that's our r value, 15. And turn the 15% into a decimal, 0.15. And when you subtract it, you get 0.85. So there's my equation. 9,000 times 0.85 to the power of t. Okay? Then in the scenario, it says use the formula and plug in the number 3 to see how much the vehicle is going to be worth after 3 years have passed. Okay? And after 3 years has passed, since your vehicle price is going to depreciate, or meaning it's going to get smaller, that's why your number is smaller than 9,000. Okay, it's at $5,527, which makes sense because, like I said, it's going to depreciate in value. Okay. All right, so I think we can finally get to our first problem that's going to be live. And I already took the pleasure of boxing things that are going to be important in the problem. So when you guys get to your problems, please make sure you guys either highlight or box words or numbers that are going to be important as you guys go on your journey towards getting your answer. Okay, so let's start identifying what these guys are. So the 20 is going to be your a value. Okay, so I'm going to put a little a next to the 20. And your 35 is going to represent your r value, so I'm going to write that as a decimal, so r equals 0.35. The word dissipates, okay, that's a pretty uncommon word. So it means to basically like dissolve or disappear or get smaller, basically. So since it says that, we're in the scenario called b equals 1 minus r. Okay, all right. And the 4 is going to represent, after we get our formula, we're going to plug 4 into it. Okay, and on this first blank right here, right, we're gonna frame our equation. We're gonna put a times b to the power of t. So my a value is 20, so I put a 20 there. Then I gotta figure out my b value. So let's run my equation. So it's gonna be a b equals 1 minus r scenario. So basically b equals 1 minus 0.35. And when that gets computed, we get 0.65. So that's going to be my b value. So I'm going to put a 0.65 in the parentheses. And then I'm going to put it to the power of t. So we just made the symbolic representation for this problem. Or you can call it like your formula, right? So now we're going to use the formula and plug in 4. So let me do that work on the bottom here. So we got 20 times 0.65 to the power of 4. And you're going to need your calculator for this. So when you plug in 0.65 to the power of 4, you're going to get a big decimal, and it's going to look like this: 0.1785 0625. Okay, and you're going to multiply that number by 20, and when you do that, you're going to get 3.570125. Okay, and I believe so it doesn't really say what you're going to round to. So if we don't tell you what you want to round to, just go to 4 decimals. Okay, so if we don't tell you what to round to, just assume that we want you to go to 4 decimals. All right, so the number that's sitting in the 4th spot is a 1. So we look at the 5th number, which is a 2. And is the 2 strong enough to turn the 1 into a 2 as well? No, it's not. So your final answer is going to just be 3.5701. Okay, and you're going to drop that number on this line. And luckily the label is already there. Okay, so in other situations, maybe we might take away the label, right? So if we ever eventually have a quiz on this, which we're not, but if we're eventually going to have a quiz on this, then sometimes we would take away the label and see if you guys can figure out what the label is on your own, or sometimes we would leave it there and pretty much give you a gift. Okay, so don't assume that the label is always going to be there. And probably when you get to your high level math classes, they're probably not going to be written for you already. Yeah, so the science teachers are going to be happy with us if we take away the label and you guys got to figure it out on your own. Okay, all right, so let's jump to number 2. Okay, so like I said, I boxed everything just like in problem 1, so make sure you can identify what's important as you read it. And if you can identify what's important, then you're going to be on the right track towards getting the answer. So 10,000, hopefully you recognize that. You're going to say that's my A value. Grows will imply that we're in a B equals 1 plus R scenario. The A of t equals A times B to the power of t. That's what my equation is going to look like. 6 is going to be the number I plug in after I get my equation, and 10%, that's my R value. So I want to write that as a decimal, so 0.10. Okay, all right, so let's start framing out my equation, but let's figure out the B value first though. So B equals 1 plus R, that's my scenario. So basically B equals 1 plus 0.10. So when I combine those things together, I get 1.1. So there's my B value. All right, so let's start putting it into my equation. So I got 10,000, that's my initial value. That's my A value. Then I'm going to multiply it by 1.1, which is my B value, and put it to the power of t. Okay, so once you identify everything that's important in the problem, making your equation is pretty easy. Okay, you just got to see the patterns, right? And one of the big patterns is, first of all, identifying, is this a growth or decay situation? And once you identify that, you can figure out if it's a B equals 1 plus R versus B equals 1 minus R scenario. Okay, so now let's start using our equation or our formula that we just made. So 10,000 times 1.1 to the power of 6. Okay, so let's start using our calculator to get these values. So 1.1 to the power of 6 is 1.771561. Okay, and then we're going to multiply that by 10,000, and we're going to get 17,000. Ooh, why is it not writing? $17,715.61. Okay, so you're going to say, oh, this doesn't have 4 decimals. And usually on all of these problems that have decimals, you told us to always round to 4 decimals, but we don't have any decimals. So you got to just read the problem carefully, and it says to round to the nearest dollar. Okay, so the nearest dollar is right here, the 5. The 5 is in the spot called the nearest dollar. So you look at the next number right behind it, and you just say, is the 6 strong enough to turn the 5 into a 6? And fortunately this time it is. So your final answer is going to be $17,716. So that's what I can put in that blank as well. And fortunately, the label is already there for you as well. So don't assume that we're going to put the labels there all the time. We're just being nice for now. Yeah, we're probably going to take it away later on. Okay, so that is it for this lesson. You guys have 6 problems to do on your own. And like I said, the advice that I want to give you is identify everything that's important first. Okay, so that you can figure out all the letters that you need to identify, right? The A, the B, and the T value that's going to eventually be used after your equation is already made. Okay? Alright, so good luck, and don't worry, if you get stuck, we'll go over this in class. Alrighty, bye-bye.